Like a test paper. Like a test case, yeah.
Like a lab mouse or something.
So we left off with parallel resistors. Does everybody have their module 3? Does anybody need another copy? Everybody's got theirs? We talked about, we're starting to learn how to do circuit analysis with basic DC circuits. And we started with series resistors. So if we have these 3 series resistors, how do we get our total resistance? Remember, we're always looking to get our equivalent model, which is just one resistive component, R total. That's what our goal is, because then we can analyze the circuit. Okay? So how do we get the total resistance when they're in series? Add them up. RT equals R1 plus R2 plus R3. When they're in parallel, so let's go back to series. Series, the total is always going to be larger than the largest resistor. It has to be, okay? You add up the resistance. When we're in parallel, do you guys remember the formula? How do we find our R total on this one? Yep. 1 over R1 plus 1 over R2 plus 1 over R3. And remember the 1 over, when we invert it, that's the same thing as saying RT with an exponent of -1, which is on everybody's calculator, equals R1 to the power of -1 plus R2 to the power of -1 plus R3 to the power of -1. So we have our formulas on how to do it. I think that before I set you guys loose on trying to do some of these examples, I'm going to do one together so that you guys get a better feel for what you're doing. So I'm going to draw this circuit. And I have 3 resistors in parallel. Much like the LEDs you guys did when you designed your card. R1 I have at 150 ohms. R2 I set is 200 ohms. And R3 is 180 ohms. And our source is 50 volts. What we're going to try and find is what's our total current is the question. What's our total current and what's our total power? Those are the 2 components we need to find out to do the analysis on this circuit. We know these are in parallel because they're all connected here at ground, they're all connected at this node, and they're all connected at this node. They're all connected together at each end, so they're in parallel. So let's look at this. What would you do first, given that we have these equations? What's the, huh? Plug the numbers. Which equation? To find what? Find the current? Yes, we have to find the total current first so we can get to this. RT and voltage source. So we have 1 over RT equals 1 over 150 plus 1 over 200 plus 1 over 180. So RT is going to equal 150 inverted plus 200 inverted plus 180 inverted, and that whole thing is inverted, right? You guys remember that from your calculator when we did it yesterday? Let's see if everybody agrees on an answer. Make sure you can put this in your calculator to get the answers. You'll be doing this hundreds of times. 58.1 ohms. Did anybody else get the same answer? Everybody? We're good? 58.1 ohms. So now we have this 58.1 ohms for our R total. Our voltage source is 50 volts. What would be the next step? We want to find our current and our power. Ohm's law. Ohm's law for here. We can find our I total. And remember, that current is the same in both models, leaving the source. Leaving the source. So this is, how are we going to find it? Remember, Ohm's law says voltage equals current times resistance, and it's good for a component in the circuit. What would I plug in here? IT equals what? Say it. Volts divided by resistance. Voltage total divided by resistance total. So it's 50 volts divided by 58.1 ohms. What's that come to? 816 or 60? 60. 860 milliamps. Do you have your calculator set on engineering notation? Yeah, it's a lot of calculators you can set it on in engineering notation, but then you have to pay close attention. If you don't, your calculator is going to come up with 0.86. Okay, 86. You have to know that, then be able to convert it to milliamps. 0.86, so we got 860 milliamps. How do we calculate our power total? I want two equations with what the information we have that we can use to find our power. What two equations? Just give me two. Say again? IV. What's another one?
Resistance times current R2.
Yep. I squared R. This one is commonly used as commonly as that one is.
And then you could also do voltage squared divided by resistance.
Yep. V squared over R. I worked a little stint in utilities, in a utility company. Didn't like it, so I left it. But we use this a lot. I squared R. Comes out a lot. Okay, power total. Let's plug these numbers in. So this is going to equal, let's use I squared R, 860. Make sure you're in amps squared times our R total, 58.1. What do we get?
43.1 watts.
43.1 watts.
Yeah. I got 43 on the nose, but
43. Did anybody get anything else? 43. Okay. So make sure you just put the 0.86. That seems high, but it kind of makes sense, I guess. Yeah, that makes sense. So that's how we do an analysis of a parallel circuit. So what I want you to do is just try a couple. I just put a couple examples in here so you guys get some practice. I need to know that you know what you're doing before I throw you out there for the quiz and the homework.